North America is dripping down into Earth's mantle, scientists discover. Seismic mapping of North America has revealed that an ancient slab of crust buried beneath the Midwest is causing the crust above it to drip and suck down rocks from across the continent. An ancient slab of Earth's crust buried deep beneath the Midwest, sucking huge swatches of present-day North America crust down into the mantle, researchers say. The slab is the pool has created giant drips that hang from the underside of the continent down to about 400 miles deep inside the mantle, according to this new study. These drips are located beneath an area spanning from Michigan to Nebraska and Alabama, but their presence appears to be impacting the entire continent, of course. The dripping area looks like a large funnel, with rocks from across North America being pulled towards it horizontally before getting sucked down. As a result, large parts of North America are losing material from the underside of their crust, the researchers have said. A very broad range is experiencing some thinning, study lead author Junlin Hua, a geoscientist who conducted the research during a postdoctorate fellowship at the University of Texas at Austin, said in a statement. Luckily, we also got a new idea about what drives this thinning, said Hua, now a professor at the University of Science and Technology of China. The researchers found that the drips result from the downward dragging force of a chunk of ocean crust that broke off from an ancient tectonic plate called the Farallon Plate. The Farallon Plate and the North American Plate once formed a subduction zone along the continent's west coast, with the former sliding beneath the latter and recycling its material into mantle. The Farallon Plate splintered due to the advance of the Pacific Plate roughly 20 million years ago, and remnant slabs subducted beneath the North American Plate slowly drifted off. One of these slabs currently straddles the boundary between the mantle transition zone and the lower mantle, roughly 410 miles beneath the Midwest. Dubbed the Farallon Slab, at first imaged in the 1990s, this piece of oceanic crust is responsible for a process known as cratonic thinning, according to the new study, which was published March 28 in the journal Nature Geoscience. Cratonic thinning refers to the wearing away of cratons, which are groups of Earth's continental crust and upper mantle that have mostly remained intact for billions of years. Despite their stability, cratons can undergo changes, but this has never been observed in action due to the huge geologic timescales involved, according to the study. And now, for the first time, researchers have documented cratonic thinning as it occurs. The discovery was possible thanks to a wider project led by Hua to map what lies beneath North America, using a high-resolution seismic imaging technique called full waveform inversion. This technique uses different types of seismic waves to extract all the available information about physical parameters underground. This sort of thing is important if we want to understand how the planet has evolved over a long time, study co-author Thorset Baker, Distinguished Chair in Geophysics at UT Austin, said in a statement. Because of the use of this full waveform method, we have a better representation of that important zone between the deep mantle and the shallower lithosphere, the crust and upper mantle. To test the results, the researchers simulated the impact of the Farallon slab on the craton above using a computer model. A dripping area formed when the slab was present, but it disappeared when the slab was present, confirming that the theoretical, at least, a sunken slab can drag rocks across a large area down into Earth's interior. Dripping beneath the Midwest will not lead to changes at the surface anytime soon, the researcher said, adding that it may even stop the Farallon slab sinking deeper into the lower mantle and its influence over the craton wanes. The findings could help researchers piece together the enormous puzzle of how Earth came to look the way it does today. It helps us understand how do you make the continents, how do you break them, and how do you recycle them, Becker said. This is by Satya Par in Life Science. Please leave your comments and thank you for your support. My Patreon account, the daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.